Okay, so I just wrote a little program this morning. Here I have a 2x2 grid.
That's not on screen.
Oh, it's not? Thanks for letting me know. Alright, so here I've got a 2x2 grid. And I make a table that has 4 numbers in it. Num times num. A second table that has 4 numbers in it. And then I pick my random integer.
Alright.
The way Mathematica picks random integers, I go from 0 to the integer. So I actually, for our 4x4 square, I pick random integer up to 3.
Okay.
And that picks a random integer 0, 1, 2, or 3, and then I just add 1 to it.
Okay.
Right?
Yep.
So then I go through and I count the number of times each number appears.
Okay.
And then I make a grid out of that. So I'll just run it. Is this on screen?
Mm-hmm.
Yeah. Okay. So the number of times 1 appeared was 1, the number of times 2 appeared was 2, the number of times 1 appeared was 1, 2 appeared was 1, 3 appeared twice, and 4 appeared no times. In my little practice set of dice rolls here.
Alright.
Okay. And then this number 4 here is the size of my matrix, or the size of my grid here, 4, divided by the number of times 0, the number of numbers that had 0 times. So this time only one number had 0 times, so I get 4.
Alright.
Okay. So the number of entries equal to 0 is 1, the number of entries equal to 1 is 2, the number of entries equal to 2 is 1, and then obviously I didn't have it anytime where I got 3 entries the same. Okay, but we could do this by hand with our 2x2, but let's go up to a 5x5 and see what we get. Lost the mouse, where is it? There it is. Okay, so maybe I'll zoom in on the grid here. Do you want to tell me what this is saying? Like, what does this 0 mean?
0 means the number 1 didn't appear at all.
Okay, and how about this 2?
2 means the number 2 appeared twice. 3 appeared once. 4 and 5 didn't appear at all.
Okay.
6 appeared once, and so on.
All right, great. And actually this number, which is, let's see, 1, 6, 11, 16 actually appeared 3 times. So did 17.
Yep.
And the number of entries equal to 0 was 9. So I got 9 entries equal to 0 in this case. And 25 divided by 9 is 2.77. Okay, so maybe I can run it again. Oh, look. When I ran it again, did it run again?
Yeah, I think it did. Yeah.
It's just below that.
Yep. Yeah, it ran again.
Okay. All right. Yeah, it ran again. I was a little confused. I'm not sure why this part is appearing up here. Let's get rid of that. So here, I definitely have a new grid here, but this time I had 10 zeros. First time I had 9.
That's your previous.
Yeah, I don't know what's happening. Now I'm back to having 9 zeros.
Alright.
Okay. Do you notice anything about the number counts or anything in the grid that you find interesting?
Well, I don't think we would have 4 yet. I think we've just had 3. So the highest we've had is a 3, and we only had 1 of them here.
Okay, so in this case we had the number 1, 2, 3 actually appeared 3 times.
Yep.
Okay. Do you think we ever could get a 4?
Probably if you
yeah,
ran it
yeah.
enough.
All right, let's see. Well, no 4s, but again I got 9 numbers that didn't appear.
So we're always staying around. We've always gotten either 9 or 10 zeros.
Yeah, that's interesting, but we still have never had a number appear 4 times.
Oh, the
No,
only ones
no
in
3s here.
No 3s. Oh, this time I only had.
7.
Yeah.
7 zeros.
3.5 about.
Back to 9, but also no
No threes.
So it's interesting. So the numbers are spreading out a little bit, but we're not. Oh, got a 4.
Got a 4.
Okay, and what number is that appeared 4 times?
We had
16.
16.
16. Okay. Anything else you're seeing in our 5x5 grid?
Not really seeing any pattern in like the zeros and the 1, but I guess that would be part of the randomness of it.
Okay.
Well, the zeros are kind of hovering around 10ish. Sometimes it's a bit
Yeah.
more, sometimes actually it's more closer to 9 probably because we've got a lot more 9s.
Okay. Anything you notice about the ones? The number of ones?
Number.
It's always seems to be less than the zeros.
Oh, it seems to be less than the zeros. That's interesting.
So we had 8 this time.
All right, let's see. Let's see if that holds true.
No, not here.
Not this time. Okay, this time it was a little bit more. I wish I could make that previous one not appear. Ooh, wow, this time it was a lot less. And we'll just run it one more time. With our 5x5 grid. Oh, this time it was
Yeah.
more.
So I know
Okay.
that kind of fluctuates.
All right, so do you have any guesses or conjectures you want to make about the number of zeros or the number of ones?
Well, so I think, well, this time it's the lowest I've seen here is 7, and the highest I've seen is 11. So maybe it hovers between maybe like 7 and 12.
Okay.
I'm gonna say maybe like we could say 0.3 and 0.4 of your number of squares.
Okay.
And 2 by 2 we had, I think we had 1 until we ran it. So I could have just, that was about 2.25. So
Okay.
yeah, maybe.
Interesting. Yeah, and I'm looking at the reverse of what you guys are looking at. I'm looking at this total number of squares divided by the number of zeros.
Yeah.
Well, that might approach pi.
Ooh, interesting, yeah.
I mean, we've got a 3, so maybe as it gets larger, you never know.
Okay, all right, let's go on and let's make it be larger.